Okay, gang, the very last video in the statics series, other than the conclusion, of course. Hallelujah. Okay, let's talk about area moment of inertia using the calculus method. Okay, we've been talking about composite shapes method, and you're going to use that on anything you can. Okay, but if you happen to have one that is just about a completely wacky shape, right, that's not in the back of your book, you're like, I don't know, then we use the calculus method on that one. And this is the definition in your book. So Ix, when you want to find Ix, it's the integral of y squared dA. When you want to find Iy, it's x squared dA. So just remember that it's, and we talked about this in the last video, right? Because if you're doing it about the y-axis, you have to find the x distance, right? And if you're finding about the x-axis, you have to find the y distance. So that's why for y, it's x, and for x, it's y, okay? So they ask us here to find Iy, I'm going to put y, about the y-axis, okay? So this time, and you got to read in the book, okay? The book doesn't always want you to take the centroid about the neutral or the centroidal axis. Sometimes it's about one of the coordinate axes, and you have to read that, okay? So if it's about that, you don't, if it's about one of the coordinate axes, you don't have to use the parallel axis theorem, because there is no perpendicular distance to the axis, okay? So that's one nice thing. So in this particular problem, they asked us to find about the y-axis. So about the y-axis, what is Iy? So we're going to use this equation here. And we're going to go back to centroids by calculus, and we're going to do it the exact same way again, okay? So to find Iy, you take the integral of x squared dA. Okay, so you're going to multiply x squared times one differential area. Do you remember how we did differential areas? Remember what I suggested to you was we draw one strip. Okay, so there's one strip, let's say. And we remember, do we remember how wide one strip is? I remember. I don't know if you do or not. It's dx wide, right? So what we're going to do is this. We're going to do the integral. Iy is equal to the integral of x squared times dA, okay? Uh-oh. And dA is a differential area, one little rectangular strip, and a strip is width times height. So what goes in there? What's the height of that strip? Okay, I'm going to draw you two arrows. Here's one. Here's two. So the height of that strip is 2 minus whatever this height here is, which is some y height, isn't it? Gosh, if that equation was just solved for y instead of in y squared, let's do this. Y is equal to square root of 2 times x to the 1/2. Let's do that. Okay? So the height of that little strip right there, of that one little strip, is 2, the whole height, minus this bit down here, root 2 x to the 1/2. Okay? And of course, what's our limits? Remember, we had to stack a book, so stack of strips, and our strips go from 0 to 2. Okay? And it's really in the x direction. I don't know if you put 0 to 2, was it this one or is it that one? Well, it's really this one this way. Okay? And what do we do? Let's expand this. Let's distribute this guy. So this becomes the integral from 0 to 2 of 2x squared minus root 2 times x squared times 1/2. Now x squared is really x to the 4/2, isn't it? So x to the 4/2 times x to the 1/2 is x to the 5/2. Okay? Okay, here we come. We're integrating. So 2 times x squared turns into x cubed over 3. Okay? Minus root 2, there's the constant. X to the 5/2 turns into 2/7 x to the 7/2, doesn't it? Okay, and again from 0 to 2, okay? So this becomes, oh, 2 times 2 times 2 times 2, right, is 2 to the 4th over 3 minus root 2 times 2/7 times 2 to the 7/2. 7/2 is really like 3.5, isn't it? Okay? That just makes it a little bit easier to put in your calculator, doesn't it? Okay? So let's do this. Here we go. 2 to the 4th divided by, 2 to the 4th divided by 3 is 5.33. 333 minus, okay, here we go, root 2 times 2, whoops. Need to learn how to use my calculator better. Root 2 times 2 divided by 7 times 2 to the 3.5 equals, that's 4.571. So here we go. IY is equal to 5.33333 minus answer equals 0.762. Okay. 0.762 what? Okay, what were we doing? What are these distances in? Meters, right? Area, meters squared. X squared, distance squared. It's meters to the 4th. All right, so centroids by calculus really helps us out on this one. It's a one differential area times x squared gives you the IY. And that's all there is to it. That's the calculus method. Okay, gang, that's going to wrap up statics. Stay tuned for the conclusion, and I hope you made an A in this class. See you next time.